power rule, it should say rule right there, and more review. So let's start taking derivative of each one of these. So the first one here, 2x cubed minus 3x squared plus 2x, they want to take a derivative. So this is f prime of x. All we're going to do is bring it down, subtract 1 off. So I should get 6x squared minus, bring 1 down, subtract 1 off. 6x. Remember, anytime it's a linear term, there's just an x or just a variable, then it's just a coefficient. So in this case, 2. And there you go. That's a derivative. Next one, g of z. So same idea here. We're going to take a derivative. So just using the power, we'll bring it down, subtract 1 off. So I'm going to get negative 21z to the negative 4 plus, same thing here, bring it down, subtract 1 off, 2z. And then this is a constant, and the derivative constant is always just 0. So there's my derivative. Then we go down to f of x right here. F of x equals 2x cubed minus 10x to the first. So we're just going to take the derivative. Bring it down, subtract 1 off. So 6x squared. Bring it down to become a positive 10x. Subtract 1 off. So negative 2. Okay, moving on. So now this one, I can't just take the derivative right away. I've got to rewrite it first. So to put in the form so we can take a derivative. So we're just going to write this as 6t to the 1/2 power plus 1 over t to the 1/2 power. Right? All square root is 1/2 power. Now that's better, but still not perfect. I gotta rewrite this. So I can't have this on the bottom here. So I gotta move it up. So 6t to the 1/2 plus t to the negative 1/2. Right? When you bring it up, it becomes a negative. And now I haven't done any calculus yet. I haven't taken a derivative. So now we can take a derivative. So h prime of t equals, bring the 1/2 down, subtract 1 off. So I get 3t, common denominator is 2 over 2, so 1 minus 2 is negative 1/2. Plus, I spoke too soon, it's not plus. So negative 1/2, t, subtract 1, common denominator, 2 over 2. I get negative 3/2. So there we go. That's our answer. Remember, you could leave it like this in IB, so you don't have to be a hero and try to make it all nice. IB is totally fine with that. So the same thing with these. So I want to take a derivative, bring it down, subtract 1 off, 24y cubed. Bring it down. Now here's a little funky. I got 7 times 2/3. So I'm going to do it over on the side. That's 7 over 1 times 2/3. Right, so remember, constant always over 1 if you're not sure. Then you just multiply straight across. 14 over 3. So this is plus 14 over 3. Y, and then I got to subtract 1. 2/3 minus 1, common denominator, is negative 1/3. Next one. So just like the one we did earlier, I got to rewrite these. So let's rewrite it before we do anything. So this is s to the 1/4 plus s to the 1/3. So now it's rewritten. Now we just take a derivative. So bring it down, subtract 1 off. 1/4 s to the common denominator, negative 3/4 plus 1/3 s, subtract 1, 3 over 3, negative 2/3. There's our answer. This one. So that there's an e here. Remember, to me, e's are the easiest ones. They're just, the derivative e is just e. So nothing happens to the 3. It's in front, stays in front. Derivative e is e. Over here, bring it down, subtract 1 off. So minus 3x squared. Done. The next one. There should be something you know right away about this one. Maybe not right away, but there's no variable here. This is just a number. That's right. Just a number. The derivative number, like the derivative 5, is just 0. That's a constant. So the derivative is just 0. Any constant 0. Let's move on. Ooh, some stats review. So the stat review question, let's look what they give us. So it's the Venn diagram problem. So they give us probability of A is 0.3. So remember, keep in mind, a lot of people put A right here at 0.3. A is the whole circle. So I like to put it on top here, so I know it's the whole circle. And I'm not going to circle it because I can't circle well. So A is the whole circle, not just this guy. Probability of B, which is this, all of this, is 6. So same idea. The whole circle is 6, not just the little inside part. And then probability of A union B equals 0.7. So remember what that is? A union B is all of this all put together. So that's all that. What do they want us to know? Write down the value of T. So T is the outside. Well, if both of these circles put together is 0.7, anytime you do percent or decimals here, that means the whole union, the whole universe is 1. So all we have to do is 1 minus 0.7, because that's what all this is, to get 0.3. Alright, so again, we're going to do the universe, which is 1. Anytime we're talking about decimals in here, the universe is always going to be 1, and then 1 minus all the 2 circles gets us 0.7. 1 minus 0.7 is 0.3. Next, show R is 0.2. So the way we do that is, since we know there's the formula we always use. It's in our formula sheet. It's this guy, our favorite formula. Probability of A union B equals probability of A plus probability of B minus probability of A intersection B. And that is in our formula sheet. So we're going to use this formula. A lot of times to define what this is, but we know they gave it to us, 0.7. Probability of A, they gave it to us, 0.3. And the probability of B is 0.6. And I'm looking for this guy. So just a little math. You could subtract 0.9. I actually like to keep myself positive, so I'm going to add x and subtract 0.7. So I get x equals 0.2. Which is really just r. R equals 0.2. Let's erase that x. So r is 0.2. So go back up here, plug 0.2. And now they want to know what Q and S are. Well, go back to this thing, right? If the whole circle is 0.3 and the inside is 0.2, this must be 0.1. And then likewise, 0.6 minus 0.2 is 0.4. Okay, next part, write down probability of not P. So there's a couple ways to do this. One way is, since we know B is right here, is 0.6. What's not that one circle? Well, it's this part right here, 0.1, and it's the outside, which is 0.3, so 0.4. But honestly, the way I like to do this is, anytime I see probability of not P, I just do 1 minus probability of P. B. I think I've been saying P the whole time. I'm B. Probability of B. Anyway, so probability of B is 0.6. They tell us up there. So I just do 1 minus 0.6, and I get 0.4. So I get the same answer either way. But for me, it's a little cleaner. Yeah, if they're asking for probability A or B or something, and you have it, or not A or not B or something, and you have A or B or something, just do that. It's a lot easier. Okay, so now the tough one for most people, given that. So that is the formula in your formula sheet. It's the probability of A given B not equals probability of A intersection probability of not B over probability of the second one. Like that. It's in your formula sheet. It's usually not BA. I think it's usually BA, but you just gotta match it. So that's for some people that's the toughest part. So I think it's normally BA. You just gotta match the letters when you plug it in. So I get this. And really all it is figuring out what this is and plugging it in. Like not B, done, got that. Not B is 0.4. A intersection, not B. So you gotta think about that logically here. So we want A, and I want A, and where not B intersects with it. So this is B, what's not B? So where does not B and A intersect? Right here, 0.1. Only part they have in common is this intersection, so 0.1. Meant this. So my answer is going to be 0.1 over 0.4, also known as 1/4. Okay, let's move on to the final problems here. Next one, we're going to take a derivative of t to the radical 17. I know radical 17 looks scary, but you just do it the same way you do everything else. It's a number, so we're going to bring it down, subtract 1 off. So rad 17t, rad 17 minus 1. That's all I could do, because I don't know what the radical 17 is. It's like 4 point something minus 1. Next one, they want to take a derivative of x to the fourth, and then after we take a derivative, they want to sub in negative 2. So let's take a derivative, bring it down, subtract 1 off. So it'll be 4x cubed. And then we're going to plug it negative 2 into that. So it'll be 4 negative 2 cubed. That'll be 4 times negative 8. Remember, odd power keeps the negative. So negative 32. Last couple. T to the 2/3. When we take a derivative, then we're going to sub in 8. This will be a little uglier. So bring it down, subtract 1 off. 2/3 t. Now subtract 1 off, so 3/3, common denominator. I get negative 1/3. Now, since I'm actually going to sub in 8, I'm going to make it a little prettier. I'm going to do this. 2/3 times 1 over the cube root of t. Again, I'm only doing that because I'm going to sub in a number, and it's a little easier to sub into that. So now let's sub in 8. So 2/3 times 1 over the cube root of 8, which is just 2, so 2/3. So 2/3 times 1/2, which is 1/3. Let's erase that. There we go. Okay. And then the last one, t to the negative 2/3, and we're going to sub in 1. 1 should be easy to sub in. So it's really the hard part is taking the derivative. So bring it down, subtract 1 off. I'm going to get negative 2/3 t to the common denominator, negative 5/3. Now when you sub in 1, everything kind of just goes, well, let's sub in 1. I should do the work and not talk. I'm sure you feel like that most of the time, but whatever. So I get this, and then this. 1 to any power is just 1. So all I really do is get negative 2/3. And there we go. That's the worksheet.